Now let us the next problem type, which is based on relative motion. A ball is projected vertically upward with an initial velocity of 50 meters per second at t equals to 0. At t equals to 2 seconds, another ball is projected vertically upward with the same velocity. At t equals to, like we have to find the time the second ball will meet the first ball. So we have to find the times from the beginning. Right, so from the ground, we have thrown a ball in the upward direction with a velocity of 50 meters per second. And after 2 seconds, let us say it has reached this particular position. And what should be the velocity? Let us find this v, right? So we can apply first equation of motion, v is equal to u plus at for the first ball. So v, u is 50, I'm taking upward as positive and downward as negative. So minus g and times t. And t time is 2 seconds. 50 minus 10 times 2, so that will be 30 meters per second. So it will be 30 meters per second. And what is the displacement? Let us find the displacement. So this displacement will be, we can apply second equation, s is equals to ut minus half g t square.
So before I start solving this, if you're preparing for JEE or NEET and you feel stuck with concepts, strategy, revision planning, or question solving approaches, then you can check out Pracbee. At Pracbee, students can book personalized one-to-one mentorship sessions with experienced mentors to get individual guidance based on their own strengths and weaknesses. Now with that said, let's get into the question and see the smartest way to solve it.
So it will be 100 minus 20, which is 80 meters. Okay, so displacement is 80 meters. Now we are releasing this, now we are throwing the second ball. So let me show that instant. So we have the first ball, now we are throwing the second ball with certain velocity, same velocity, right? So that is 50. And at this instant, the velocity of the first ball is 30. And the distance between them is 80. Now we can apply relative motion. So if I observe ball 2 with respect to ball 1, so let us study second ball with respect to first ball. So when we are observing second ball with respect to first ball will be at rest. So initial velocity we can say of second with respect to first, it will be u2 minus u1, and u2 is, and I'm taking upward as positive, so u2 is 50, u1 is 30, so that will be 20 meters per second. Acceleration of 2 with respect to 1 will be a2 minus a1, both have same acceleration g, so that will be 0. So it means with respect to first ball 2 is moving uniformly, it is having a uniform motion, and the distance between them is 80. So it means the second ball is covering, so the distance between them is getting reduced with what speed? 20 meters per second. So we can say the time of meeting will be distance upon speed, so that will be 20, distance will be 80 divided by speed, relative speed is 20, so that will be 4 seconds. And we have thrown second ball after 2 seconds, so the answer will be 4 plus 2, so it should be 6, right? Now let's say this question, train is moving along two parallel tracks towards the north with a speed of 72 kilometers per hour, and train B is moving towards south with 108 kilometers per hour. Velocity of B with respect to A and the velocity of ground with respect to B. So that's what we have to calculate. So let me show you two parallel tracks. So let us, these are two parallel tracks. And this is the train A, which is going towards north, and its speed is 72 kilometers per hour, and we have to find answer in meters per second. Let us first convert this into meters per second. So 72 times 5 by 18, so that will give us 20 meters per second, and this is 108, so 108 times 5 by 18, so that will give us, so it will be 2 1 2, so 6, so 30 meters per second. Okay, so 30 meters. So now we know the speeds. So this is 20, and there is another train which is coming in the south, going toward the south direction with 30 meters per second. So velocity of train B with respect to A. So let us assume upward direction is positive. So velocity of B with respect to A will be velocity of B minus velocity of A, and that will be minus 30 minus 20, right? So that will be minus 50 meters per second. And velocity of the ground with respect to velocity of B. So velocity of ground with respect to velocity of B will be velocity of ground minus velocity of B, and ground is at rest, so that will be 0 minus velocity of B, that will be minus of 30. So that will be 30 meters per second. So in this question it should be given like which direction we have to take a positive. So I have taken upward as positive, and I'm getting option 3 as the right answer, right? Let us say this question: two cars are traveling towards each other at a speed of 20 meters per second each. When the cars are 300 meters apart, both drivers applies brake and the cars retard at the rate of 2 meters per second square. The distance between them when they come to rest. So let us see. Again, I'm going to solve this with relative motion. So there are two cars. And they're traveling towards each other. So it is coming in this direction 20, and this is the another car which is moving in the left direction with 20, and the distance between them is 300 meters. Right, so let me call this car as 2, this car as 1. So let us study 1 with respect to 2. So with respect to 2, initial velocity of 1 with respect to 2 will be, so I'm taking right direction as positive. So u1 minus u2, so u1 will be 20 minus u2 will be minus 20, so that will be 40 meters per second. Acceleration, so they are retarding, so the acceleration of 1 will be in the left direction and the acceleration of 2 will be in the right direction. So a1 acceleration of 1 with respect to 2 will be a1 minus a2, acceleration of 1 will be minus 2, and acceleration of 2 will be plus 2, right? It is in the right direction. So this comes out to be minus 4 meters per second square. So now we got the acceleration of 1 with respect to 2. So what should be the displacement? So they are, and finally, when they come to rest, final velocity of 1 with respect to 2 will be 0, right? Because both will come to rest. So we can apply the third equation of motion. So velocity of 1 with respect to 2 will be equals to initial velocity of 1 with respect to 2 plus 2 times acceleration of 1 with respect to 2 times displacement of 1 with respect to 2. So this will be 0, and it comes out to be 40, and acceleration is minus 4, so that will be minus 8. So this will be s of 1 with respect to 2. So it will be 40 by 8. So that will be a displacement of 1 with respect to 2, which is 5 meters. So it means so, sorry, it should be square. So I forgot to take the square. So it will be 40 square. So this comes out to be 1600 divided by 8, which will be 200 meters. So it means now the displacement, now the distance between, now the displacement of 1 with respect to 2 is 200, and the initial distance between them was 300. So the distance has decreased by 200. Now the distance between them when they come to rest is 100, right? Option 2 is the right answer. Okay, a passenger sitting in train A moving at 90 kilometers per hour observes another train B moving in the opposite direction for 8 seconds. If the velocity of train B is 54 kilometers per hour, then the length of the train B is, okay, let us see what we have given. Let us say this is the window from where the passenger is looking at the train B. Okay, so this is the observer. So when the, let us say, and they are moving in the opposite direction, right? So it is going in the left direction, train B is going in the right direction, right? So when the front of the train B is aligned with the window, then the passenger will start watching the train B, right? So I'm going to solve this problem again. I'm going to use a relative motion concept. So since the velocities are in the opposite direction, velocity of train B with respect to train A will be VB minus VA. So I'm taking right direction as positive. So VB is 54 and we have to find answer in meters. So let me convert 54. So 54 times 5 by 18. So that will be 3. So 15 meters per second, and 90 can be converted as, so this will be 210. So it will be 25 meters per second. So VB is 15 minus of minus 25. So that will be 40 meters per second. Now we are observing with respect to A. So the train A will be at rest. And now when the rear of train B is aligned with the window, right, up to that point, that time the passenger will be able to see the train B. Okay. So what is the displacement of train B with respect to train A? It is nothing but the length of the train B. So let us say length of the train B is L. So distance will be speed into time, and time is given as 8 seconds. So we have to find L. So that will be 40 times 8. So it will be 320 meters. So 320 meter is the answer of this question. Right, let us say this question. Two balls A and B are placed at the top of 180 meters tall tower. Ball A is released from the top at t equals to 0. And ball B is thrown vertically down with the initial velocity of u at 2 seconds. After a certain time, both the balls meet 100 meter above the ground. Find the value of u. Okay, right. So let me show you the situation. So we have given a tower and its height is 180 meter. And we have released a ball A from the top at t equals to 0. And ball B is thrown vertically down with the initial velocity u at t equals to 2 seconds. So first let us find the state of ball A after 2 seconds. So after 2 seconds it will acquire some velocity and its distance from the ground will decrease. Let us say the first ball reaches at this particular point B, or not B, let us take this point as C, and its velocity is V. So we can say V is equals to u plus 80. We can u plus 80. So u is 0, A is 10, and t is 2. So that will be 20 meters per second. So this will be 20. Now what is the displacement? So displacement will be half 10 t square. That is also 20 meters. So this displacement is 20 meters. Okay, right. So now we are throwing ball B with certain velocity u in the downward direction and at t equals to 2 seconds. And A is having a velocity in the downward direction which is 20 meters per second, and the distance between them is 20 meter. Right, so after certain time both ball meet 100 meters above the ground. Suppose they are meeting at this particular point, 100 meters above ground. Right, so so they meet at this particular point. So what is the so the distance, initial distance between them is how much? The initial distance between them is 20 meters, and the height, the distance of the first ball from 100 meter mark, this distance will be how much? So that will be 180 minus 100 minus 20. So that is nothing but 60 meters. Okay. So we know the displacement of the first of the ball A when both the ball meet at 100 meters above the ground. So we can find the time, right? We can find the time when they meet. So what is the time? So we can say, we can apply S is equal to ut plus half at square for the first ball. So S will be 60, U is 20 times t plus half, acceleration is 10 t square. Now from this we can eliminate 10. So it will be t square plus 40 minus 12 equals to 0. And this can be written as 6t minus 2t minus 12 equals to 0. So t comes out to be 2 or minus 6. So we can ignore negative value. So we know the time taken by the ball A up to the meeting point, right? So we know the time. So and the distance between these two balls is decreasing with the relative velocity. And what is the relative velocity? That will be u minus 20. So u minus 20 is the relative velocity, and speed is equal to distance upon time. Distance is 20 between them, and time is 2 seconds. So u is nothing but 30. So option D is the answer. Right. Now let us see this question. A boy reaches the airport and finds that the escalator is not working. He walks up to the stationary escalator in time t1. If he remains stationary on the moving escalator, then the accelerator takes him up in time t2. So if we have a escalator, if it is at rest, the time taken by the boy is t1. But if the escalator is moving and the boy is at rest, the time taken is t2. If the escalator is, and we have to find the time taken by him to walk up on moving escalator. So let us say the velocity of the boy on a still escalator is v, and the velocity of the escalator is u, and this distance which the boy is covering is x. So t1 will be distance upon speed, and t2 will be distance upon speed. And if both are moving, then the velocity of the boy will be u plus v. So t3 will be distance upon speed. Now from these three equations we have to find t3. Let us eliminate x. So x can be written as x, u and v. Nothing is given. So what we're going to do, let us find v, right? So v is x by t1 and u is x by t2, and from here we can find v plus u. So v plus u is x times 1 by t1 plus 1 by t2, and from this v plus u is x by t3. Now from this equation and from this equation we can find the relation between times. So x by t3 is equals to x by t1 plus x by t2. So 1 by t1 plus 1 by t2 is equals to 1 by t3. So t3 comes out to be t1 t2 divided by t1 plus t2. So option 3 is the right answer. Now let us see this question. A butterfly is flying with a velocity 4 root 2 meters per second in northeast direction. In this particular direction, 45 degree, right? With a velocity of 4 root 2. Wind is slowly blowing at 1 meters per second from north to south. So wind is blowing slowly from north to south in the downward direction. This is east, this is north, this is south, and this is west. And this is given as 1 meters per second, and the butterfly is moving in this particular direction with 4 root 2 meters per second. The resultant displacement of the butterfly. So the velocity of butterfly in ground frame will be velocity of butterfly with respect to wind plus velocity of wind, right? So which is nothing but, so let me call this as velocity of butterfly with respect to wind, and this will be velocity of wind. So vector addition of these two. So velocity of butterfly with respect to wind will be 4 root 2, and let us take the component, right? So 4 root 2 times cos 45 I cap. I'm taking right direction as x-axis, upward direction is y-axis. So that will be 1 by root 2 I cap plus 1 by root 2 j cap plus minus of 1 j cap. So this comes out to be 4 I cap plus 4 j cap minus j cap, which is 4 I cap plus 3 j cap. Now we got the velocity of the butterfly. So the resultant displacement, so the displacement will be, it is moving uniformly. So displacement will be v times t and vb times t, and this will be 4 I cap plus 3 j cap times the time, which is 3 seconds. So it will be, let us take the magnitude of this, 4 I cap plus 3 j cap times 3. So it will be, magnitude of 4 I cap plus 3 j cap is root of 16 plus 9 times 3. So it will be 5 times 3, so 15 meters. So option 4 is the right answer.